You are trying to find an integer for which x square is equal to 2. Let's try it out. The square of 0 is not equal to 2. Square of 1 not equal to 2. The square of 2 is not equal to 2. Sets are a way of mathematically representing a number of elements. For example, we have a set V equal to A, E, I, O, U. This is just set of all the vowels in English language, and they don't need to be related to each other. These are independent elements inside a set. For example, you can say that there is another set, for example A, which contains a number 2, a number 3, a name Fred, etc. So in computer science we need to use sets a lot of times because we have data, and data is arranged in some kind of sets, and we use those sets for doing some kind of operations on those elements. This method of representing elements in sets is called the roster method, and a set builder notation is opposite to roster method. So this was roster method. The opposite to this is called set builder notation, and set builder is something which uses certain definitions. Like for example, you can denote all the positive integers as z plus. We can define a set as, let's say the name of the set is O. It is defined as x, where x belongs to all the positive integers such that x is odd and x is less than 10. So this is a fancy way, you can say, of representing some integers, and those integers namely would be, so if you expand x, you can simply write 1, 2, 3, 4, 5, 6, 7, 8, 9. So you could do this, or you could also write this. Both of these ways are correct. So these are two different ways of writing the same thing. Similarly, there are different names for different kinds of sets. Like these are natural numbers, and these are all the integers. These are all the positive integers, and these are all the rational numbers. Then these are all the real numbers. These are all the real positive numbers, and these are all the complex numbers. So these are all the names for different types of sets which are out there. So all the sets belong to a certain part of these sets, which are called subsets. So we'll look at them shortly. So similarly, there's a closed and an open interval. So if something like this is mentioned somewhere, this means that x such that x is greater or equal to a and less than or equal to b. Right? So this is called closed interval. In contrast to this, we can also have an open interval, right? X such that x is greater than a and less than b. So x is any number which is from this number to this number, but here what we are doing is we're specifying that the interval is open. That means that the number x is in between a and b, but a and b both are not included in this set. Either of these things could be open or closed. So there could be this thing, or there could be this thing as well. So one side is open and one side is closed. Similarly, two sets are equal when both of these sets have exactly the same number of elements and exactly same elements. Equal sets. A and B are equal sets if and only if, for all x, if x belongs to A, then x also belongs to b. This is if and only if x belongs to a, if and only if x also belongs to b. That means these two sets are going to be equal. Then there is something called an empty set. Empty set is also called a null set, and it is used to represent that a set has become empty. There is no element in this set, also represented with phi. So this is an empty set. This is also represented with a phi. This is not equal to phi. This is a set containing phi, right? And this is an empty set. So by definition, this is not an empty set. This is a set which contains another null set. Then we have something that we call the subset of a set. So subset of a set is, for example, we say that A is a subset of B. It is just to specify for all x, if x belongs to A, then x also belongs to B. This imposes a condition on A and not B, right? So an example of a subset would be, for example, A is equal to positive integers and B is all the integers, so we can say that A is a subset of B. This is one example. Similarly, for every set, phi is a subset of that set. And similarly, the same set is a subset of itself. So then there is a definition called a proper subset. And proper subsets are those subsets which are where, for example, we have A equal to 1, 2 and B equal to 1, 2, 3. So now A will be a proper subset of B. Size of a set, or sometimes we call it cardinality. For example, in this example, this was B. So we say that size of B is equal to 3. There are 3 elements in this set. So this is the cardinality of this set. Similarly, another definition called power set. Power set is the set of all subsets of a set. So for example, we have a set 1, 2. There are only 2 elements in this set called 1 and 2. So the power set of this set 1, 2 will be first the empty set, then 1, then 2, then 1 and 2, because they are the subsets of the same set as well, right? So this is called a power set. Similarly, we have another definition, Cartesian product. Cartesian product is, for example, we have A equal to 1, 2 and we have B equal to A, B, C. We define the Cartesian product of A and B as A cross B, which is equal to the set of pairs of all the elements from A to B, like 1 comma A, 1 comma B, 1 comma C, 2 comma A, 2 comma B, 2 comma C. So these are all the elements of a cross product or Cartesian product of A and B. So the Cartesian product A cross B is not equal to B cross A. So you should try it out. So because whenever you do B cross A, you will be doing A comma 1 and not 1 comma A, and A comma 1 is different from 1 comma A. So that's why these two things are different. Then there is another definition which is called truth set. In set builder notation, we normally have the value of x which is not immediately revealed. It is described using some expressions. So we have to find out the elements x for which that statement is true. For example, you have a set P equal to, you have a definition of set P equal to x, which belongs to all the set of integers such that x square is equal to 2. So you need to find out all the values of x for which x square is equal to 2. Because you are trying to find out an integer, you are trying to find an integer for which x square is equal to 2. Let's try it out. The square of 0 is not equal to 2. The square of 1 is not equal to 2. The square of 2 is not equal to 2. So we all know that there is one number, I wouldn't say an integer, there is one number which is somewhere like this, which exists in between these two integers 1 and 2, for which this statement would be true. But then x would not be an integer, it will be a real number. Since this is not possible, that we are not able to find an integer for which this statement is true, we will say that the truth value of this set P is null, because there is no such number exists which is an integer and x square is equal to 2 for that number. Similarly, for example, you have defined a set Q which is x belongs to all the integers. This is a set Q for which x belongs to all the set of integers and x. So you have to find the truth set for this. So the truth set for this would be is the set of all the integers for which x modulus is equal to 1. So you can say that truth set of Q is equal to plus 1 comma minus 1, because plus 1 and minus 1 are both the numbers for which the absolute value would be equal to 1. Truth set of this Q would be this, right? These were some definitions for sets. And then there are set operations. You may be familiar with all of these things from earlier, that's why I'm going a bit fast. So set operations are all the operations on multiple sets. You can say that Cartesian product is an example of that, but it doesn't necessarily change the set. It just takes out pairs of elements from both the sets, using both the sets. So first set operation is called union, and it is denoted by A union B if we are talking about the union of two sets A and B. So for example, you have a set A which is equal to 1, 2 and 3, and then you have a set B which is 2, 3 and 4. So A union B would be 1, 2, 3, 4, which leads us to another definition which is the opposite of union, which is called intersection. So intersection is defined as A intersection B. So for these examples, all the elements which are common between both the sets A and B. So in this example, they are 2 and 3. So this is the intersection of A and B. Similarly, the difference of two sets. Difference is defined as A minus B. So from the same example, if we were to do A minus B, we will keep all the elements of A which are not in B. 2 is in B and A, 3 is in B and A both, but 1 is the element which is only in A and not in B. So that will be the only element in A minus B. Similarly, what is B minus A? You will look at all the elements again. You will keep the element of B which is not in A. So B minus A would be 4. So it gives you another idea about the difference operator, and which is that the difference operator cannot be the same if we are reversing their positions. So A minus B is not equal to B minus A. So there are different identities of sets. I'm not going to go into the detail right now, but just to give you an idea that if you take complement of A 2 times, you get A back. So this is one of the set identities which is called complementation. Similarly, the De Morgan's law, and yes, De Morgan's law is the same as the we did for propositions. So A intersection B whole complement equals A complement union B complement, and similarly A union B whole complement equals A complement intersection B complement. Similarly, there is something called the absorption law or absorption identity. This is also similar to that from the propositions part. A union of A intersection B equals A, and A intersection of A union B equals A. So you can see here that union is similar to the OR operation in logic, and intersection is similar to AND operation of logic.